All right, welcome back. We're going to continue studying linear equations in this lesson. In the last lesson, we focused primarily on achieving slope. Today, we're going to graph them. So let's take a look at our first example. Our first example is to graph this equation that's written in standard form. So we're going to state the slope, the y-intercepts, and the x-intercepts, which is basically just all the most important information about the line. So first thing I'm going to do is get the x-intercepts of this particular line. So an x-intercept occurs when a graph crosses this axis here, the x-axis. The y-axis up here, where it crosses that is the y-intercept. So what I'm going to do is I'm going to replace the y value with 0. And solve that equation. So any point on this x-axis where the line crosses, that y-coordinate has to be 0. So if I put a 0 in for y, I can solve for that x-coordinate. Now 4 times 0 is 0, so that just becomes like that. And then 3x minus 0, anything minus 0 is just itself. And then I get x is equal to 8 when I divide both sides by 3. That's a 24, not a 29, by the way. All right, so 1, 2, 3, 4, 5, 6, 7, 8, right there. All right, let's find the y-intercept. And if you don't mind, I'd like to, start to do this a little bit quicker. So on the y-intercept, the line, wherever the line crosses this axis, the x-coordinate there is always 0. So I'm going to put a 0 in for that one. Okay, 3 times 0 is 0, and then 0 minus anything is just negative that. So it just goes away, right? And I'll divide both sides by negative 4, which gives me a negative 6. So 1, 2, 3, 4, 5, 6. And then I just kind of draw the line through there. All right, and that's it. I do like to put little arrows on my lines, and I hope you do too, because I want you to know they keep going forever. Now, it did ask us for the x-intercept. We have that at 8. We've got the y-intercept at negative 6. We might want to make that more explicit by saying something like x-int is at 8, 0. The y-intercept is at 0, negative 6. As long as I know what you mean, though, I'm sure it's fine. The slope, now we can just simply count it from here. 1, 2, 3, 4, 5, 6 over 8. Up 6 over 8 reduces to up 3 over 4. We could also solve this equation. We could do just a quick little algebra here to solve for the slope. So 3x minus 4y equals 24. I'll subtract 3x from each side. So I have a negative 4y equals a negative 3x plus 24. Divide both sides by a negative 4. And remember, we have to distribute there if we're going to divide this. So negative 3 divided by negative 4 is a positive 3 over 4x, and then a minus 6. These are the same lines. This line and this line are definitely the same line, but this form allows me to see the slope as 3/4. Please do not put an x when I ask you what the slope is. The slope is a number. It is not a number x. It is in front of x in y equals mx plus b form. But don't put a variable when I ask for the slope. That's not correct. All right, let's take a look at another example. Okay, I've got 2x minus 7y equals 14. Again, I'm going to start by finding the x and y intercepts. We could also solve the equation for y and do it that way. So to find the x-intercept, I'm going to put a 0 in for y. And I'll solve the relating equation. So 2x minus 0 is just 2x. And I'll divide both sides by 2, and I get x is equal to 7. So our x-intercept is at 7. And now I'll find our y-intercept by putting a 0 in for x. 2 times 0 is 0. 0 minus 7y is a negative 7y. Please don't forget the negative. That would be bad. Divide by negative 7, you get a negative 2. So I'm going to make a line kind of like this. If I can get it just right. Right? There we go. So that's our line there. And the slope, I like to go ahead and solve it for y to get the slope usually. And when you the more you practice this, the more you can actually do this in your head, which is where I'd really like you to be. So I get y is equal to negative 2 over negative 7 is a positive 2 over 7. And then at times x minus 2. So we can see that the slope is 2 over 7, which is up 2 over 7 here. Up 2 this way, over 7 that way. All right. Okay, got another example before you get to show what you got. X equals 7 is a vertical line, it should be, through 7. So if we think about it, the x-intercept is clearly 7, right? 1, 2, 3, 4, 5, 6, 7. That's clearly the x-intercept. But there's no y value at all, so it has no y-intercept. And the only way you could be a line that has no y-intercept is to just be a vertical line. And that's one explanation for why it's a vertical line. There's I could give other explanations for why that is. But I want you to memorize that. I want you to immediately think vertical line when you see x equals a number, horizontal when you see y equals a number. Every point on this line has an x coordinate of 7. That's the requirement for the line. The y can be any coordinate, but the x must be 7. That's going to make it a vertical line. So we know that the x-intercept was 7, 0. There is no y-intercept, and there's no slope to speak of also. So we say the m is undefined. Okay, you've got yourself, looks like, a few different practice problems. So please take your time, do your best on it, and then we will go over them as soon as you're done. Okay, I've got 2x minus 8y equals negative 8. The x-intercept on this one, we'll put a 0 in for y. That gives me 2x equals negative 8. So x equals negative 4 is the x-intercept. 1, 2, 3, 4. The y-intercept for x. And I get negative 8y equals negative 8. So y equals negative 1. No, it doesn't. It equals positive 1. What am I doing? I'm about to say that doesn't look right. Divide both sides by negative 8, you get a positive 1. Which gives me a line something like that. The slope of this line, it should be up 1 over 4. All right, let's take a look at your next equation. We have x plus 3y equals 6. We have an x-intercept, which we can find by plugging in 0 for y. I think you'll agree is just 6. We can plug a 0 in for x to get the y-intercept, and you'll get y is equal to 2. So 6 and 2. There we go. X-intercept was 6, y-intercept was 2. What about the slope? Well, on the other one I counted. Let's just solve this one for y. Move the x to the other side by subtracting x from each side. I'll divide both sides by 3. I got to divide each one of those. But that's a negative 1/3 because there's a 1x there. And then plus 2. So the slope is negative 1/3. Okay, I think you had one more. I accidentally called it A again, but I think you figured it out. All right, y is equal to negative 4. That is a horizontal line where all the y coordinates are negative 4. So I should have seen a horizontal line right there. It has no x-intercept. It has a y-intercept, obviously, of negative 4. And the slope is 0. So a horizontal line has a slope of 0. All right, next I want to cover graphing equations of lines that are in slope-intercept form. So let's look at a couple examples of that. All right, we've got y equals negative 2/3 x plus 7. So, and this is kind of your old standby slope-intercept form. We were graphing earlier using x and y intercepts, but you can always convert it to slope-intercept. It's always going to work well. So let's find 7. 1, 2, 3, 4, 5, 6, 7. And then I need to count a rise over run of negative 2/3. So I go ahead and just put the negative to the top. So I need to go down 2 and to the right 1, 2, 3. And I don't have any grid lines on these, but these are just kind of little sketchy graphs. But I think we get the idea there. Okay, so we already know the y-intercept. The slope-intercept form tells you that's the slope and that's the y-intercept. So that's nice. We get the slope and the y-intercept, but we don't get the x-intercept. So in standard form, you get x-intercept and y-intercept pretty quickly, but you got to work for the slope. So a little different. So I'm going to find the x-intercept again by putting a 0 in for y. But I think you'll notice we have a bit more work to do this time. I could get rid of the fraction right now, though, so I'm going to do that. I'm going to multiply both sides by 3. I could also subtract the 7 first, if you'd prefer. That would work as well. 3 times 0 is 0, and I get negative 2x plus 21. And now I'll subtract 21 from each side and divide by a negative 2, and I get positive 21 over 2, which is about, what is that, about 10.5. And it looks like my graph's a little off there, but that's okay. All right. Let's do another example. All right, I got 2x minus 15. All right, well, this graph does not really work well for that. We could count by 2's on the y, but my y-intercept is negative 15, so it's not going to fit well if I count by 1's. So slope equals 2, y-intercept is equal to negative 15. But I'm going to show you something that I can do. I can use my slope to generate points from any location. So I'm going to go ahead and plug in, let's see here. I'm going to plug in a number like x equals 4. So f of 4 would be 2 times 4 minus 15. Well, that's 8 minus 15. That's a negative 7. So what that tells me is that 4 goes to negative 7. So I don't have to change my scale if I want to do it this way. 1, 2, 3, 4, 5, 6, 7. Now from there, my slope is up 2 over 1, up 2 into the right 1. So it gives me a pretty good idea what the graph looks like, even though I can't see the y-intercept. So just another way to do them. You could renumber the y-axis, or you can plug in an x value, find something that works, whatever you prefer. So let's find the x-intercept. Put a 0 in for y. I'll add 15 to both sides. And divide both sides by 2, and I get 15 divided by 2, which is about 7.5. Last time I did a lot better. No, last time I was too short. This time I've gone too far. Maybe it would have been more like that. What do y'all think? That looks a little better, right? 1, 2, 3, 4, 5, 6, 7.5. Okay. Well, I don't care. It's close enough. I trust our math, and our graph is always just a sketch, especially since I don't have the grid lines on here. Okay, well, you have 2 practice problems to do. Please take your time, do your best on them, and pause the video, and we will go over them. All right, let's see how we did. Slope is told to you right there in the equation. It's -3. We have a y-intercept of 6. And check out that form, y of x. I really like that form. It's kind of neat. It's function notation, just like f of x, but it's y of x. So, which makes sense because y is a function of x. I always kind of like doing that. Show you that it can at least. All right, so 1, 2, 3, 4, 5, 6. There's the y-intercept. I'm going to go down 3 to the right 1. I'll do it one more time. Down 3 to the right 1. Because that's going to tell me my x-intercept, isn't it? Oh, I can't do this. All right, let me grab my line tool. There we go. So we have a y-intercept at 6, and it looks like an x-intercept of 2. -3 times 2 is -6, plus 6 is 0. So I'd say that one's done. Okay, let's take a look at this one. Okay, got a y-intercept at -4. Got a slope this time of 1/5. And we're going to go up 1 and over 4. So we're not going to go up very much here. We're going to be really flat. I don't think we're going to see the x-intercept anywhere on this graph. Let's solve for the x-intercept. So I'll put a 0 in for the y-coordinate of f of x. Add 4 to each side. So this time I added 4 before I multiplied by the 5, which I certainly have a right to do, and I'll multiply both sides by 5 here. Doesn't really matter how you want to do that. And I get 20 is equal to x. So yeah, that's way going to be beyond what we can see. All right, I want to say that we have one more type to talk about, and then I think we're going to be able to mix them all up together. At least I hope so. So let's take a look at an example of a line written in point slope form. All right, so to graph a line in point slope form, you have, of course, the option to convert the line to slope intercept form if you prefer. If you like the point that you're given, now let's go ahead and plot that. So the point that I'm given is -1, +4. So it's always the opposite of that number and that number, okay? And our instructions is not asking us to identify the y-intercept or x-intercept, which is pretty typical in a situation where you would use point slope form. You wouldn't be that interested in the x. Well, you might be, but what I'm trying to emphasize here is the point and the slope. That's the important information in this particular example. So the slope is always that number in front of x. So its slope is -3. The thing that's multiplied times the x minus the point. So the point that we go through is the opposite of that number with x, so it's a -1, and then the opposite of the number with y, so it's a +4, and then the slope is -3. So find the point, -1, 4. And then I'm going to count down 3 and to the right 1. Down 3 and to the right 1. Like so. All right, let's try another one. All right. So on this one here, I'm going to find the point to be at, remember, the opposite of the number with x, so 5, comma, the negative of the number with y. Opposite with x, opposite with y. So 5, negative 2, with a slope of 1/3. So I'm going to count up 1 over 1, 2, 3. I could even go backwards if I want to do that as well. But I think you see the idea here. And there's the line. All right, again, you have a couple practice problems, so please try that. And then pause the video, try it, and we will go over it when you're done. Okay, I hope that wasn't too bad for you. I hope there weren't too many curveballs. So this one here, the point, the value with x is actually nothing. So there's a 0 there, comma, and then the value with y, the opposite is -1. So it's 0, -1 is the point, and the slope is down 2 to the right 1. So it looks something like that. All right, on the next one, we have a point at opposite with the number with x is 2, opposite number with y is 1. So 2, comma 1, and we're going to do a slope of up 1 over 2. And I want to say it's going to go right through the origin, it looks like. All right. So let me post this right quick, what we've learned in this lesson so far before we start kind of mixing things up as a grand finale here. So in this lesson, we've looked at 3 different forms of the equation. I did not put these kind of forms out in front at the beginning because I like to start with the numbers in there. But these are the 3 forms: standard, slope-intercept, and point-slope form. This is not the only ways you can see lines written. Different people like them in different ways, but these are the 3 that I will use. With standard form, we can quickly get the x and y intercepts by simply plugging a 0 in for x and solving for y, and plugging a 0 in for y and solving for x. Slope intercept tells you the y-intercept, that's the b value, and the slope, which is the m. Point slope tells you the slope and some point somewhere on the coordinate plane. So quite often, though, you'll find that lines and equations won't necessarily come pre-packaged in one of these forms, in which case you need to put it in one of them. Which form? Whatever works easier for you. Sometimes it's a simple conversion to make it slope-intercept, or a simple algebraic step to make it in the standard, whatever works for you. So take a look at these last couple of practice problems from practice 4.4 and try and put it in a form that makes sense to you, and then graph it. All right, let's see how you did. So I look at this form and I think, okay, this is fairly close to y slope-intercept form. So that's what I'm going to do. I'm going to subtract 7 from each side. And then I'm going to divide both sides by 2. And I have to divide each one of these. So I get 3 over 2x minus 6. So I know that my y-intercept is at -6. And my slope is up 3 over 2. It looks like my x-intercept then must be at 4 just by using the slope. All right. Now let's take a look at the next one. Okay, well, this form is actually in standard form already, but in this case, it's not very helpful to graph. If I try and find the x and y intercepts, I'll find that the x-intercept is 0 and the y-intercept is 0. So it just gave me 1 point, not enough to graph. So it's got, when you have standard form equal to 0, it's pretty much going to require you converting it to a different form. Let's put it in slope intercept. So I'll divide both sides by -5, and I get 2/5 x. That tells me the slope of up 2 over 1, 2, 3, 4, 5. So yeah, that standard form where you graph it finding the intercepts, it doesn't always work that well if it's equal to 0, so you want to go ahead and convert that. So just to finish the lesson for your exit ticket today, I want you to write down some notes about how you would find the slope of a line in each of the three forms we looked at, because each one is kind of similar but kind of different. So, and that's all for today. So until I see you again, take care.